All right, let's get through this lesson quick, because then we can have a lot of work time. All right, most of us might be able to get most of our problems done. I do want to start off the lesson really quick by saying tomorrow I will not be here. Well, just for this class.
Where are you gonna, what?
I'm going with the international students down to Illinois. Oh, you won't be there either? Okay.
Just our class.
But Miss Urbanski will be in here, substituting for me. No, Mrs. Urbanski. Tomorrow's going to work like normal. You're just going to pull off your lessons from there. It will just be more practice problems, all right? So you're just going to come in and get started on the practice problems. I'll put the solution key over there as well. It also will be posted online. I know it's a no homework weekend, but there's enough time to A, either get it done, or B, get most of it done. So on Monday, all I'm going to do is I'm going to check your homework, make sure the homework that was from today is done, and then I'll check to make sure you gave a valid effort on the practice problems, all right? So that means you can't just have one done and say, I ran out of time.
I'm gonna give it my all.
Nice.
As Miss Ray always says, get her in, get her done.
That's something. Okay, so just so you're aware, I will not be here tomorrow, so there's no shock. All right, so you could split this up into two fractions. You could slowly simplify stuff down. You could actually get to the answer that way, splitting it up. It's going to take several steps and a couple nice little tricks in there. But the easier method would be to see that I have cosine cubed, and I don't want cosine cubed. I don't want cosine cubed. And I have a cosine here. So whenever I have two things that I don't want to deal with, one of these, I'm going to see if I can factor it out of everything. So my first step is just factoring out a cosine x. And sometimes factoring is the hardest thing to see in these. So I factor out a cosine x, which will leave me sine squared x plus just cosine squared x all over sine of x. So when I pull that cosine out here, it comes out front, and I pull one of these guys out here, so I'm left with two of them, but sine squared plus cosine squared, that just equals 1. So this whole right here just equals 1. And then we have cosine over sine. Cosine over sine just equals cotangent x. So by far, that is the simplest way to solve this one. But you have to be aware that factoring things out is a nice practice to do when you don't like what you're working with. All right? And it might have, this kind of tips me off. Cosine cubed usually tips me off that I might have to pull something out because I can't do anything with cubes. All right? So that's one more trick we got to think about, factoring something out. It'll help us later on. All right, any questions on how I solved that one? Does it make sense? Something you could do probably, as long as you saw it. Like I said, all these take practice. The more times you practice them, the more you see, the more you kind of see these tricks, and you can kind of think ahead. All right, second thing is, what questions do we have from the homework? None? That's cool. Oh, Lizzie. 71? That was the easiest one. I'm just kidding. It wasn't. No, it wasn't. So I'm just going to talk about 71 really quick. So 71, obviously I'm not gonna work on the sine to the fourth side because that one's already pretty much condensed and simplified. So I'm gonna work on the other side. And what I see on the top is 1 minus cotangent squared plus cosine squared times cotangent squared all over cosecant squared. So on the top there, that cosine squared and cotangent, I see cotangent squared appearing in two different places. And having cosine squared and cotangent squared next to each other, we might think about changing the cotangent to maybe cosine over sine, but then we get to cosine cubed, and that doesn't seem like I'm simplifying something, so that probably isn't the best option. So what I'm going to do is, if we're all looking at it, I'm going to kind of forget about that 1 being out front. All right, so if I forget that 1's out front, I just have negative cotangent squared plus cosine squared times cotangent squared. And just looking at it that way provides me the option that I could factor out a cotangent, in fact a negative cotangent squared out of both of those. So let me go ahead and take a picture of what I did, and I'll walk you through how I did it.
Is anything like this going to be on like a test?
Sure, why not?
How can you just like forget about the one? I don't understand how.
Well, you don't forget about it. I'll show you what I mean. So you don't forget about it, you just kind of leave it out front. Right, Will? Since you asked that question. We just kind of leave it out front. But I'm just focusing on this negative cotangent squared and this cotangent squared, and I'm saying if I pull that negative cotangent out front, I'd be left with just 1 here, and I'd be left with just the cosine squared. And 1 with cosine squared is usually a nice thing, because I can usually write it as sine squared or something which would reduce stuff down. But I need to pull out a negative cotangent squared. So for just right now, because we can always tack that 1 on later, what I kind of think about is that 1 isn't there for a second. All right, I think about that 1 not being there, and I covered up too much of it because I need the negative sign. Let's make this a little bit smaller. So just for the time being, I kind of don't think about that 1. I know it's going to be out front, but it can just hang out front. It's just going to stay out there no matter what. So I'm looking at this, and I'm saying, well, if I pull out a negative cotangent squared, I'm left with 1 here. So that's where I got the 1 from. And if I pull out a negative cotangent squared here, it's going to turn this positive into a negative. And if you don't believe me, distribute it. Because distributing this back in would give me a negative cotangent squared, and this would be a negative times a negative, which gives me a positive. All right, the whole goal of this was I don't want this cotangent squared attached to this. Because cosine squared, most of the time, we're going to be able to change it to sine squared as long as there's a 1 attached to it. So I factor everything out, and then I go ahead and put my 1 out in front. That 1 does not affect what I factored out. But after factoring it out, I'm left with 1 minus cosine squared. And that was my goal, because that reduces down to sine squared. And then I'm thinking about cotangent. Cotangent is just cosine squared over sine squared. So that means my sine squareds would cancel out, and I'd be just left with 1 minus cosine squared on top again, which factors down to sine squared. Yeah, Logan.
How is negative cosine in the parentheses?
Here?
Yeah.
Because I actually pulled out a negative sign.
Oh.
All right.
That applies even though it's not.
Yeah, let me do that again. So I'm actually pulling a negative out of here, right? A negative cotangent out of here. And if I pull the negative cotangent squared out of here, I got to change that sign to a negative. If I pull out a positive cotangent, then it would stay positive. But I'm pulling out a negative, so I need to change this sign.
Then where's the 1 coming from?
The 1 was just hanging out on front the whole time. It was just chilling out front, like, hey, man.
Where did it come from inside the parentheses?
Oh, where did this come from?
Yeah.
It came from right here. If I pulled, like, let's say I have x minus x squared, right? And I factor out an x. So I'd rewrite it as x times 1 minus x, right?
Okay, yeah.
Same thing with cotangent. I'm actually pulling this negative cotangent out front, so I'm left with just the 1. So it's kind of hard to draw, but basically I took that negative out and pulled it out front. And I pulled this cotangent out front, but I was actually using a negative, so I had to make it negative. All right, and then once you do that, all the rest of the steps we can do. It was just this one hard factoring step that's hard to kind of see and know how to do, especially with the negative sign, because it'd be easy to have 1 plus cosine squared, at which point you'd be completely stuck. Because 1 plus cosine squared doesn't equal anything. All right? We okay with that? Is this that one big step? Logan, you still look angered by it.
No, I'm just
Taking it in?
together.
Oh, okay. Should I leave it up here for a bit?
No, you're fine.
Okay, it's also posted online, right? What was that? 53. 50 trace. So the big thing about 53 is that note that I put on the bottom. And the note I put on the bottom, I believe, is that sine squared of negative x is actually the same thing as sine squared of regular x. I know sine of negative x, we pull that negative out front. But if it's squared, we don't have to, because you think about if I have negative 2 squared, it just becomes a positive. Same thing with sine. So sine squared of a negative number automatically makes it positive. So how would you rewrite this? I'll pull that down. So with sine of negative x, we actually pull out the negative sign. Let me put that in red, which would make that positive. That's where that positive came from. And because it's squared, the negative just disappears. So we are just, well, it doesn't really disappear, it just gets squared and becomes positive. So we're just left with sine squared x plus sine of x all over 1 plus sine x. Once again, on top, I have a bunch of sines, so I'm going to factor out a sine of x, which in the inside is going to be sine of x plus 1. That's going to cancel out. I'm left with sine of x. Next question. Yeah.
It's not really one from the homework, but our test, is that the Tuesday we come back from, right? Like next Tuesday?
No.
No.
That'll be the following Tuesday.
Okay.
And real quick, so some of you might have an honors biology test that day. And if you don't want to have both those tests the same day, you can take mine Monday. And if you're really stressed out, so that'll be the day before. We kind of have 2 review days for this because I don't like putting tests on Monday, because we have a review day and everyone kind of forgets it over the weekend. But if you'd want to, you could take it on a Monday. And if you're really stressed out, come talk to me and we could possibly move it to the Wednesday after. But I'm not wanting to do that, but just in case. All right, just so no one's freaking out. Because that should be you should only have 2 tests that day per the test schedule. All right. Other questions on the homework? Sammy? 65. Ooh. I like 65. We're actually going to practice one just like 65 in the homework today. In the very short lesson we have. Okay. So 65, I'm just going to talk about it with you. So we have 1 over cosecant theta minus cotangent theta, and then we have equals 1 plus cosine theta over sine theta. So in my mind, I look at that 1 plus cosine theta, and I'm thinking multiply by the conjugate. All right, anytime I have that 1 plus something, I immediately think multiply by the conjugate and see what it gets me. So I multiply the top and bottom by 1 minus cosine theta. Before I show you the answer, I'm just going to talk about the other side looks pretty complex too. All right, so this might be one of the ones that I have to work on both sides independently. So what I did, and I put it up there, is I multiply by the conjugate. All right, multiplying by the conjugate gets me 1 minus cosine squared on top. On bottom, I would just get sine times 1 minus cosine, because I didn't distribute. My sines actually cancel out. I'm left with sine theta over 1 minus sine theta. This feels like a good stopping point because I can't really simplify more stuff down here without going into some weird, really I can't do much here. So this is a really good stopping point. But I'm going to say to myself, well, these two things aren't equal yet. So it's a good sign that I have to work on the other side. Now the other side, I can't split this apart because it's the denominator. I can't write this as 1 over cosecant minus cotangent. That doesn't work. So I can't split it up. So all I'm going to do is I'm going to rewrite the cosecant and cotangent. But that leaves fractions over fractions. Well, if I just gave you 1 over sine theta minus cosine theta over sine, and I ask you to get rid of the fractions, you'd probably distribute, like you'd multiply by sine all the way across to get rid of your denominators. Well, what I do to the bottom, I have to do to the top. So I multiply the bottom by sine theta to get rid of these fractions. But that just means I need to multiply my numerator by sine theta as well. And as soon as I do that, I distribute this to the 1. I have sine theta on top. These cancel all our signs, so we're just left with 1 minus cosine theta. And in fact, we are done. All right, so this is kind of the one that we just, there's only so much we can possibly do, especially when we have cosecant theta minus cotangent, and this one just ends at sine theta over 1 minus cosine theta. Does that make sense, Sammy?
Yeah.
Does that seem like something you could do if you saw it again? Good. Next question. Cool. All right, you should have plenty of time to fill this in. I'm just going to do the Pythagorean identities with you really quick. If you couldn't fill it in the time I gave you to do the bell work and stuff, you need to practice these. Like I said, so the Pythagorean identity, I don't memorize all 3 of them. The only one I have memorized, and I know year to year, is just cosine squared x plus sine squared x equals 1. That's the only one I have memorized. Because now what I do, if I was taking a test, I would just write this on top. And then I would do my next one. And to do the next one, I'm just going to divide everything by cosine. All right, and I can do that in my head generally. Because cosine squared divided by cosine squared is just going to be 1. And then I'm thinking sine squared divided by cosine squared. Sine's on top, so that must be tangent. And finally, I have 1 over cosine squared. 1 over cosine is secant, so that must be secant squared x. Then to get my third one, I just think about dividing by sine squared. Cosine squared divided by sine squared, that's cotangent squared. Plus sine squared divided by sine squared is just 1. And finally, we have sine squared divided by 1 is going to be cosecant squared x. I think that's easy to try to memorize it and remember which sides go on. If you are one of those people that just memorizes stuff, I just remember that cotangent and cosecant go together, and our secants are always on the other side. All right, and our tangent, cotangent are always on. But like I said, don't memorize it. It's so easy. It takes like a second to come up with the second 2. And you don't have to worry about where the 1 goes and which one's positive and which side stuff goes on. All right, so that's what I'd highly suggest you do rather than just memorizing all 3. All right, I am going to skip this one because it's very uninteresting. It is honestly just rewriting cosecant as 1 over sine, rewriting tangent as sine over cosine. Things eliminate, and you'll get your answer. Go ahead and do it. It'll take like no time at all, but I'm going to focus on this next one. I really just put it on there for just taking up space because this one doesn't take a ton of space up. I'd rather get done so you can start your homework. So I'm going to build my wall. Chung, 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 chung. Boom. That's a fine quality wall. That is. Do you see that guy? That's perfect. Nothing can get past that. I'm not going to mess with the negative cosecant squared because it looks as simplified as it can do. I can't do much with it. I can maybe rewrite it as negative 1 over sine squared, but that's about as far as I can go with it. So let's focus on this side. There's multiple ways we could solve this next side. We could turn the 1 minus secant squared, and we could do something. With our tangent value and change it into that, but I'm not going to do that. I'm going to pick a different method to solve this one. And with this method, I'm just going to rewrite my secant squareds, just so we can see how we can do this. So if I rewrite my secant squareds, I'm going to rewrite it as 1 over cosine squared theta all over 1 minus cosine, 1 minus 1 over cosine squared theta. I picked this one out on purpose, and I'm solving it this way because it's just like the one that was in the homework that we had questions about. If I have fractions over fractions, and everything has the same denominator, to get rid of this fraction, I need to multiply by cosine squared. But that means I need to multiply the denominator by cosine squared, but that's actually going to help us out. So if you ever have these fractions that have these same denominators, we're just going to multiply the numerator and denominator by cosine squared theta on top and cosine squared theta on bottom. And that's multiplied by 1, so I'm allowed to do that. So with multiplying, we're going to see our cosine thetas cancel out on the numerator, so I'm just left with 1 on top. And then I distribute this cosine squared here, so I distribute it to the 1, which will just give me cosine squared theta. Minus, the cosine squared is going to cancel out, I'm left with minus 1. Well, that's 1 over cosine squared minus 1. You have to be careful here, because if you manipulate the sine squared plus cosine squared equals 1, you're going to see this actually equals a negative sine squared. So that's going to be 1 over a negative sine squared theta, which is just going to equal negative cosecant squared theta. And we are, in fact, done. Let me put some equal signs to make stuff look a little better. Bring that guy down, and we're done. Yes?
Can you also, like, prove it by multiplying by conjugate?
No. Maybe. The problem with multiplying by the conjugate on this one is, see how it says 1 minus secant squared?
Yeah.
The conjugate's actually going to get you, like to the 4th power. Because your conjugate for this one would be multiplying by 1 plus secant squared, right? So it'd actually get 1 squared minus secant to the 4th. Generally, the conjugate, I'm picking ones that are like 1 minus secant theta, or 1 minus cosine, or not squared. Okay, does that make sense?
Yeah.
Why I wouldn't do that?
Yeah.
Yeah.
Can you like check my work and see if it still?
Did you do that?
Yeah.
Okay, yeah.